Systems 2.2. So, let's take a look at these first ones. It says, determining if given values are solutions to an equation. Okay, so how do we decide if something's a solution? Well, we're given these points, an x and a y value. Those x's and y's correspond to the x's and y's inside the equation. So if it's true, the equation would make sense. So let's try A. So I go 3 times 2 for x plus 2 times 4 for y equals 12. 3 times 2 is 6. 2 times 4 is 8. 6 plus 8 is 14. Does 14 equal 12? No. So that's not a solution. Okay, that's what a solution doesn't look like. So try B. Okay, so 3, put the 3 in for x, 2 in for y, so we're just substituting in the points and then solve them. 2 times 2 is 4, 3 times 3 is 9, 9 plus 4 give us, 11. Try 13. 13 is not equal to 12. Not an answer. So we just try that with every single piece. Okay, with C. 3 times 4 for x plus 2 times 0 for y. 2 times 0 is 0. 3 times 4 is 12. 12 plus 0 is 12. Does 12 equal 12? Yes. So that's a possibility. But remember, when we're dealing with two variable equations, there are more than one answer. So try 0, 6. So 0 for x, 6 for y. That's 0. That's 12. 0 plus 12 is 12, so 12 does equal 12. So C and D are both possibilities here. Okay, now number 2. We try the same thing. Okay, so 2 for x, 0 for y. 5 times 2 is 10. 10 minus 0 is 10. Does 10 equal 10? Yeah, so A is a possibility. Well, what about B? 5 times 3 minus 0 equals 10. 5 times 3 is 15, minus 0 is 15, does not equal 10, right? Not an answer. What about C? 0 for x, negative 10 for y. Minus and negatives like positive, so positive 10. 5 times 0 is 0, 0 plus 10 is 10. So C also works. And one last one, D. 1 for x, 1 for y. 5 times 1 is 5, minus 1 is 4, does not equal 10. So, there we go on number 2. Okay, so when you're checking to see if a solution works, you just plug in the x and the y. Okay, now, on 3, 4, and 5, you're kind of doing the same thing, only you're figuring out what the other part is. So we've got an x for 2, we want to know the y. So for my x, I put in a 2, and then we solve for y. So 2 plus y, so I'm going to subtract by 2. So I get y equals 4. For B, put in 0 for x. That just eliminates, so y has to equal 6. For C, now we're not putting in x, we're putting in a 0 for y. So x would also have to be 6. Okay, for 4, same idea. 2 in for x, then we solve for y. 2 times 2 is 4, plus 4y equals 8, minus 4. We get 4y equals 4. Divide by 4, y equals 1. Then we do it for the next one. So 0 for x, 2 times 0 plus 4y equals 8. We solve for y. 2 times 0 is 0, so that eliminates. So 4y equals 8, divide by 4, and y equals 2. Okay, then we do it for the C. So we get 2x plus this times our y is 0. That cancels. 2x equals 8. Divide by 2. And x equals 4. So there's our next set. So now we look at number 5. Same thing. So if you haven't yet, try it on your own and then watch the video. So 2 for x, so 3 times 2 minus y equals 8. 3 times 2 is 6, minus y equals 8. Subtract 6. Remember that negative stays with the y, and we get 2. Then divide by a negative 1. Take positive y equals negative 2. Then for b and c, 0 for x. So negative y equals 8. Divide by negative 1. So positive y equals negative 8. And then for c, 3x minus 0 equals 8. So 3x equals 8. Divide by 3. You'd have x equals 8 thirds. You could make that, what, 2 and 2/3, or 2.6. Okay, whichever one you wanted to put in there. Alright, looking at number 6. So now we've got kind of a multi-step problem here. It says solving inequalities. Follow directions for each problem below. So we've got this inequality. It says solve for x, then graph the solution on the number line. So we've got 10 minus 3x is less than 28. So to solve for x, it's 3 times x subtracted from 10. So I got to get rid of that 10, so I subtract 10. So I have a negative 3x is less than 28 minus 10 is 18. Divide by a negative 3 on both sides. And whenever with inequalities we divide by a negative, so this guy, we reverse our inequality, and 18 divided by negative 3 is negative 6. So 0, 1, 2, 3, 4, 5, negative 6, negative 7. Those should all be negatives. So x is greater than negative 6. So I draw a hollow circle because 6 is my border, it's not an answer, and x is bigger, so I shade, let's actually shade purple, to the right. Then part B says select an x value from your graph of the solution of the inequality. Replace x in the original inequality, 10 minus 3x is less than 28, with your chosen value. Does the inequality hold true? So let's do negative 3. So 10 minus 3 times negative 3. Is that less than 28? Negative 3 times 3 is positive 9. 10 plus 9 is 19. Is 19 less than 28? Yes, it is. So that's true. Now it wants me to choose a value outside my solution. So that would be out to the left. So like negative 7. So 10 minus 3 times negative 7 is less than 28. That will give me a positive 21. 10 plus 21 is 31. Is 31 less than 28? No, so now my inequality isn't true. Okay, that idea that inequality includes all those possibilities, but not the ones outside of it. Okay, number 7. Now we're kind of taking that same idea, only doing it with a 2-variable inequality. So let's think of it as an equation and graph it. So think of that as 4x minus 2y equals 6. Well, to graph it, I want to put it in slope-intercept form, right? So first, I would subtract 4x, get negative 2y equals negative 4x plus 6 divided by negative 2. We'd end up with y equals positive 2x minus 3. So my y-intercept is 0, negative 3, right? My slope would be 2 over 1, so up 2 to the right 1, 2 to the right 1. Oops. That's better. Up 2 to the right 1. or down to the left one. That's what my graph would look like. It says select a point above the line, so let's pick this point 0, 0. Replace x and y values in the inequality. Is it still true? So 4 times 0 minus 2 times 0, is that greater than or equal to 6? So 0 minus 0, so is 0 greater than or equal to 6? No. Okay, then select a point below. Let's do this one. That's 1, 2, negative 4. 2, negative 4. So 2, negative 4. So 4 times 2 minus 2 times negative 4. Is that greater than or equal to 6? That's 8. That's plus 8. That's 16. Is 16 greater than or equal to 6? Yes. Okay, so which side should be shaded? I guess you could say to the right or underneath. That side, right? Why? Because that's where we have a solution. That's where our possibilities are. Okay, decide whether the line should be solid or dotted. It's also equal to, so it means it should be solid. Alright, so let's just take a look and do some of these examples graphing inequalities. Hopefully you have the notes from class, and you've tried to do them all first on your own, and then you can take a look at what we got here. So, we got x is less than or equal to 4. There's no y here. So when there's no y, just think of it as on the x-axis, go to 4. There's my 4 on the x-axis. So it's a vertical line here. Okay, so is x less than it or equal to it? It's equal to it, so solid, less than, so we just shade to the left. Okay, number 9, y is greater than negative 5. So on the y-axis, I go to negative 5. There's no line under it, so it's a dotted line. And it says y is bigger, is greater, so I just shade above. Remember, when it's ever y equals a number, it's a horizontal line. X equals a number, or an inequality, it's a vertical. Alright. Now let's deal with these guys. So remember, the first trick is graphing these. So slope-intercept form, y-intercept to negative 4, slope negative 2 over 5, so down 2 to the right 5. Down 2 to the right 5, or use that same pattern up 2 to the left 5. Okay, now we know where the boundary is, so I have to decide, is it solid or dotted? Remember, solid is when you have the equal to. So less than and equal to or greater than or equal to. Dotted is when it's just less than or greater than. So just greater than, so dotted line. Okay, now we just have to decide where to shade. So to do that, pick a test point. My suggestion, pick 0, 0. Take your inequality, put 0 in for y, 0 in for x, and then simplify. Can't change that side. Negative 2/5 times 0 is 0, minus 4. It's negative 4. Is 0 greater than negative 4? Yes, that's true. Because that's true, I know that where the 0, 0 is the side that's going to be shaded. So I shade that same side, because 0, 0 is one of my answers. Then we do it for the same on this side. Negative 1 for our y-intercept, slope of 2 over 3, up 2 over 3, up 2 over 3. Line underneath, so it's solid. Pick my test point 0, 0. 0 in for y, 0 in for x. Simplify. 2/3 times 0 is 0. 0 minus 1 is negative 1. Is 0 greater than or equal to negative 1? It is, so that side is where we shade. If it was false, then we'd shade the opposite side. Okay, let's take a look at some more. 12. Y-intercept. Start at -3. Slope 3 over 5. Up 3 over 5. Or down 3 and to the left 5. No line, so it's dotted. Pick my test point 0, 0. 0 for y. 0 for x. Solve. 3/5 times 0 is 0, minus 3 is -3. Is 0 less than -3? No, that's false. So because that's false, this side where my 0, 0 is not the answer. So we end up shading the opposite side. Same idea. This is like plus 0, so when there's no added or subtracted number, 0 is my y-intercept. Slope of -4/5, so down 4 to the right 5, or up 4 to the left 5. Then we have the line underneath, so a solid line. Now this is the one case where we can't pick our test point 0, 0 because our line goes on 0, 0, so that's not going to tell us which side to shade. Okay, whereas here it wasn't on the line, so it could tell us which side to shade. So because of that, we're going to have to pick a different test point. So I'm going to pick 2 just to show you an example of when it works and when it doesn't. So let's pick 1, 1. And -4, -3. So pick 1, 1 first. 1 for y, 1 for x. 1 times -4/5, so 1 is greater than or equal to -4/5. Okay, is a positive always greater than a negative? Yes. So that's true, so we should say shade this side, right? Well, let's double check that. -3 for y. -4 for x. -4 times -4, positive 16 over 5. 5 goes into 16 3 times with 1 left over. Is a negative greater than a positive? No, so that's definitely false, which means that's not our answer. That's why we shaded this side. Okay, those are the one times when you can't use 0, 0 as part of your answer. Okay, now what do we do when we're dealing with these guys? Okay, this is not in slope-intercept form. The easiest way for you guys is to probably turn this into slope-intercept form. Well, how do we do that? We get the y by itself. So I'd subtract an x from both sides. So we'd have -3y is less than or equal to -x plus 6. Then we could divide everything by a -3, remembering that when we divide by a -3, we reverse the inequality. Well, x divided by 3 is like 1/3 x, right? 1 divided by 3, it's like 1x over 3. Negative over negative makes it positive. 6 divided by -3 will give us -2. So, y-intercept of -2. Slope of up 1 to the right 3. 1 to the right 3. Solid or dotted? Solid. Pick our test point 0, 0. 0 for y. 0 for x. 0 minus 2 is -2. Is 0 greater than or equal to -2? Yes. So we shade that side. Now I could have also put the 0, 0 into the x on the y here. So 0 for x minus 3 times 0 for y. 0 is less than 6. That would have worked as well. Okay, this is one way you can do this type of problem. The other way you deal with one of these type of problems is by finding the x and the y-intercept. This is the one that I would advise you against doing because it seems like this one really throws you guys off. Okay, but it may work for some of you, so do it in this case when it works. If it doesn't work for you, just kind of zoom past this and just double check your answer. Okay, and if you would have changed it to a slope-intercept form, you would have ended up with y is less than 3/4 x plus 2. So, to get the x-intercept, you make the y value 0. So, I take this and I make the y value 0. And then that becomes 0, so I'm left with 3x is greater than -8. Divide by 3. X is greater than -8/3, which becomes 2 2/3 negative. So -2 2/3, there's my x-intercept. About right there. For the y-intercept, the x is always 0. So I make the x 0, and then I solve for y. So that becomes 0. -4y is greater than -8. Divide by -4. So we get y is less than +2. So up here at +2, there's my y-intercept. Okay. Then all I have to do is say it's solid or dotted, draw my line. Okay. And then we treat it the same way we did before. Now if you change it to this format, see that you'll still get the same thing, because we started our y-intercept at 2, and we go up 3 into the over. And so I might be a little off on drawing my graph, but you end up with basically the same graph. Okay, then we pick our test point of 0, 0. Plug 0 in for x, so 3 times 0 minus 4 times 0 for y. So 0 minus 0, is 0 greater than -8? Yes. If you use this format, plug in your 0, 0, that becomes 0. Is 0 less than 2? Yes. So 0, 0 works. And so that's the side we shade. Right there. Okay? Alright, now, solving for a variable. So looking at 16, we're just solving for a variable. So, what's happening to v? Well, we'd start out by dividing by 3, then subtracting 4. We're going backwards, so we do the opposite. So we add 4 to both sides first. That becomes 0, so we have v over 3 equals -1 plus 4 is 3. Then we do the opposite of dividing by 3, we times by 3, so times both sides by 3. Those cancel, giving us v equals 9. And there we go. Okay, for 17, a few different ways we can do this. First thing I would do is try to simplify. So we can distribute the 2, which means multiply. 2 times 8 is 16p. Plus 2 times 1 is 2, minus 7 equals 107. So 2 minus 7 would give us -5. So 16p minus 5 equals 107. So add 5 to both sides. We get 16p equals 112. Divide by 16. And we get p equals some number. What is it, like? Apparently my brain doesn't want to do that, so I'm just going to use a calculator. 112 divided by 16 gives us 7. Whoop-de-doo. Alright. Simple enough with those guys, right? Okay, now solving an inequality and graphing it with just one variable. We treat it the same way. What is happening to x here? Well, first, if we knew what x was, we'd be subtracting 10 from it, and then we'd be dividing by 2. We're going backwards, so we start off by timesing both sides by 2. Okay, so let me rewrite that. -10 plus x divided by 2. So we times both sides by 2. Because that 2's under all of it, we just times it once. So we get -10 plus x is greater than 8. Now we add 10 to both sides. So we get x is greater than 18. So to graph that, go to 18. It's not equal to, so draw a hollow circle. Is x bigger? Yep, so we shade to the right. Okay, 19, same idea. So 5 minus 10p is greater than or equal to negative 45. So if I knew what p was, first we'd be timesing by a negative 10, then we would be adding 5, right? So we go backwards, subtract 5 first. So we get negative 10p is greater than or equal to negative 50. Then divide by a negative 10. And now we're dividing by a negative 10. So that reminds us, flip our inequality. That becomes p is less than or equal to negative 50 divided by negative 10 is a positive 5. So I go to positive 5, draw my circle. It's equal to, so it's part of the answer, fill it in. P is less than, so I shade to the left. Alright, last couple problems, just writing in slope-intercept form, so that's just getting y by itself. So looking at 20, we start by adding 1. So I've got negative y is equal to, now, this 3x, remember, 3x is really x plus x plus x. So if I add a 1 to that, that doesn't add another x. That doesn't become 4x. Okay? That doesn't get rid of an x. It's simply 3x is plus 1. So I leave it 3x plus 1. Then to get rid of that negative, I divide everything by negative 1. Negatives cancel. We get y equals negative 3x minus 1. 21, same idea. Okay? Can subtract a 2x from both sides, giving me negative 2x equals y plus 4. Subtract a 4. Negative 2x minus 4 equals y. If I really wanted to, I can just rearrange. Alright, there we go, guys.